All right, the next part of Unit 5, the coordinate algebra and geometry, or algebraic connections to geometry, we're going to talk about segment partition and how to partition a segment. When we partition a segment, we're going to talk about one-dimensional first. Okay, partitioning meaning to cut something into several different pieces. So you need to know the formula. It's going to be x1 plus a over a plus b times x2 minus x1. Talking one-dimensional, we're just going to talk about a horizontal distance first. So using this example here, A is at 1, so we have a point at 1, that's A. B is at 7. And we're looking to cut this line into equal pieces. Well, how we're going to cut it? It wants you to find point T, so that T partitions, or T cuts, A to B into a 2-to-1 ratio. Now, this 2-to-1 ratio is really little a to little b. That's where this fraction comes in. So, little a over little b, so a over a plus b becomes 2 over 2 plus 1, which is 2/3. So what this means to me, this means I want the second cut out of 3 total cuts. Okay? So let's use this formula here. We have x1, and I'm going to let that be a. I read from left to right. So that's going to be 1 plus my ratio, 2/3, times 7 minus 1. So again, at this point you could put it on your calculator and let it solve. I'm just going to do it by hand. 1 plus 2/3 times 6. I know that goes in here once, that goes in here twice. So 1 plus 4, that's equal to 5. So 5 is that second cut out of 3 total cuts. Well, here's how I know. I can go over 1, 2, 1, 2, 1, 2, and I have 1, 2, 3 parts of my line. So that point T is at that second point here. So let's work on this again. I'm going to pick a couple different points. Let's spread it out here a little bit. So let's try -6 to 4. Or, yeah, I think that'll work. Okay. So again, we have a ratio of 2 to 3. So that's little a to little b. So that ratio a over a plus b is equal to 2 over 2 plus 3. So that's 2/5. So that's the second cut out of 5 total cuts. So let's use this formula. We have -6 plus 2/5 times 4 minus a -6. Okay? That minus is already in my equation. So if we have a negative, make sure you're following that. So this is -6 plus 2/5, and that's going to be 4 plus 6. So -6 plus 2/5 times 10. That goes in here once, that goes in here twice. So that's -6 plus 4, so that's -2. So we have -6, that's A, 4, that's B, and -2 makes this that cut. So if we did like 1, 2, let's see, 1, 2, 3. Oh, I just put it at -1. That was stupid. Whoopsie. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that's 1, 2, 3, 4, 5. Let's practice some on our own and come back and check this example. So let's go from -4 to, where do I want to go? 1. And let's go from down here, let's go from -8 to 6. Go ahead and pause the video and come back and check your answers in a moment. I guess -2 is my favorite number for today because we should have gotten our partition point is at -2 for both 12 and 13. To gain more confidence on just using the formula, you can practice on page 37, questions 1 through 8. That's all one-dimensional partitions. Let's continue though and move into 2 dimensions. Well, 2 dimensions is like our coordinate plane, an X and a Y coordinate. So let's look at what that would mean. Well, our formula is not going to change. X1 plus A over A plus B times X2 minus X1. But if we're talking about 2 dimensions, we're going to be talking about 2 different points. So we want to talk about that second point, and it's just going to be my Y value. And it's going to be written the same. Except we'll use Y values. And I picked a terrible pen. Let's try it again. Okay. And it's just written as an ordered pair. So your final answer would be just one giant ordered pair here. So let's work on it. So I'm going to do it 1 point at a time. So I'm going to say, here are my x's, x1 and x2. So -3 plus, my ratio is 2 to 1, so that's 2/3, times 6 minus a -3. Then my Y value here, I have Y1 and Y2. So that's going to be -2 plus that same ratio, 2/3, times Y2. So 1 minus a -2. So if I'm following this, I'm going to get -3 plus 2/3, 6 plus 3. So -3 plus 2/3 and 9. So that's 1 and 3. So I have -3 plus 6. So -3 is that x value. Here I'm going to have -2 plus 2/3 times 1 plus 2. -2 plus 2/3 times 3. Those cancel. And -2 plus 2 is 0. So that point P is going to be at x value, then y value. That's the point that I can find the second cut out of 3 total cuts. So let's do one more example. Number 2 here, given the points again, so let's work one at a time. Here's x1 and y1. So we're going to have, let's see, -3 plus, my ratio is 2 to 3, so 2/5. And that's going to be 2 minus a -3. My y value here, I'm going to have y1 and y2, so that's -4 plus that same ratio, times y2 minus y1. So we have -3 plus 2/5, 2 plus 3. -3 plus 2/5 times 5. 5's cancel. So we have -3 plus 2, which is a -1. This is -4 plus 2/5, 0 plus 4. So -4 plus 2/5 times 4. Well, that's going to be -4 plus 8/5. Well, Miss Walsh, what do I do? Well, I know most of you are going to use your calculator, but let's review how to make these fractions the same. I would multiply this denominator by 5, and what you do to the bottom, you have to do to the top. So that's negative 20 plus 8, so that's negative 12 fifths. And you can leave your answer like that. So my point P is at negative 1, negative 12 fifths. Okay? A lot of your answers are going to be funny like that, and that's okay. Go ahead and pause the video and work on those next 3 examples to gain some confidence before practice, and come back here and check in. Alright, hopefully you truly paused the video because I did to work on these problems, and here are the final answers. So pause, rewind, play to double check your work. Your practice is going to be on page 37, 9 through 16. Those are 2-dimensional segment partitions. And then there's some practice word problems and maps on the back. Happy partitioning!